Madison Stephens, and I'll be presenting my Lab 1 report today. So the purpose of this lab was taking ordinary objects and some objects around our house to see how excess charge works. So some of the models and fundamental physics that we needed for this lab was one of the properties of matter, which is charge, and then the effective charge, which is basically how charges affect interactions between ordinary objects. Forces, which are interactions between objects. There are multiple. Mostly in this lab we dealt with gravitational and electrical. Momentum is the product of particles and mass velocity, which relates to force. Newton's second and third law and Coulomb's law I thought were very important during the understanding of this lab, and some of the equations are seen down below. Some important figures I thought I would include. These are taken from the lab instructions. It kind of just shows what we were doing through the lab, and especially that 8.1 to 2 diagram shows us kind of when we were treating it as a mathematical standpoint, how it would look. Some important experimental questions. These are from that first part of the lab, and I included these so you could see how I was thinking through, but really it's just me coming to understanding of how charges work between objects and how opposing charges will attract while like charges will repel. Some mathematical questions. Our tape was 8 inches or 0.2 meters roughly. The mass was found through unit conversion and a given statement. The distance that was measured with a ruler, and I said it was about 4 centimeters or 0.4 meters. The magnitude was found using F equals ma, which is 0.002 newtons. The charge on tape B was found in the as QB in the bottom right hand corner. The magnitude of electrical force is actually equal to the magnitude of gravitational force, since we know that the net force is 0. The number of electrons on tape B, otherwise known as N, in my calculations is shown below. The number of atoms on the sticky side of tape, that is also noted as A. The ratio of electrons to atoms is just a simple ratio of the above two numbers, and it shows that we are in excess. This is the first part of my coding. I won't go into detail, but this is forming the diagram you'll see on the next few slides. And then this is part 2 of the coding. Again, it's using some of the stuff from part 1, but a little bit going more in detail. This is my discussion of the coding. So these two diagrams on the left you'll see from part 1, on the right you'll see from part 2, and the results. So the gravitational and electrical force are going to be the same, but the charge on the tape will be different. Some assumptions and statements. So the initial conditions, tapes begin with no charges. Once you rip the tape off, it has charge and you move it, but the system is only considered the moving tape A, while the surroundings, including the bottom tape B. Magic Scotch tape is roughly 1 gram per meter. That came in handy with our math. Charge is evenly distributed among the surface of the tape. Each U-tape has the same charge. Air resistance is non-existent in the system or negligible, and each piece of tape is considered a point charge. Some sources of error, as well as pretty much any lab, when we're measuring things with a ruler, really hands-on, human error is possible, as well as mathematical error. I put in all of my numbers to a calculator. I could have done one calculation wrong. However, coding, the calculations are quite reasonable. And then also the charge can be affected by how the object is handled. That can change the distance. So it was very important to make sure we didn't touch the tape. Additional questions. The what if electrons and protons were switched, basically, nothing would really change other than it would be opposite. So electrons would then be positive and protons would be negative. So our terminology would simply change and the charge calculated would become negative. So when we're comparing the point charge to the line charge model, the value for Q was much larger for the line charge model, and that's probably due to the distribution of electrons. So in conclusion, this lab has demonstrated the difference in charge by using GlowScript to code different models. The line charge model proved to have a much larger charge, while the point charge had a significantly lower value, and each model returned the same values for gravitational electrical forces. Thank you.